Hi everyone! In this video we're going to be introducing logarithms and evaluating logarithms without using a graphing calculator. Let's first discuss some definitions. It says, what is a logarithm? The official definition is the logarithmic expression log base b of c is equal to or represents the value that the base b must be exponentially raised to in order to obtain the value of c. So let's look at a particular example. It says evaluate log base 2 of 8. So this means we need to answer the question 2 raised to what power equals 8. So I'm going to set this equal to x. So I'm going to convert this. So 2 to the x is equal to 8. What power of 2 raised to what power, I should say, is equal to 8? That would be 3. If the base of a log expression is 10, this is called a common logarithm and is written without a base. So if we have log of 3, it's understood to have a base of 10. So log of 3 is equivalent to log base 10 of 3. The notation ln is the natural log and it has a base of e. So for example, if I have log base of e, that's the same thing as having a log of ln of e, which is equivalent to just having ln. So anytime you see ln that has a base of e, anytime you see log that has a base of 10. Let's take a look at the next page. Convert the following equations from exponential form to logarithmic form. Okay, so we have 3 squared is equal to 9. So what we're going to do here is we're going to write log base 3 of 9 is equal to 2. We're going to keep the base of 3 and switch. So log base 3 of 9 is equal to 2. Let's look at b. 10 to the x is equal to y. So we're going to write log base 10 of y is equal to x. Remember, we might not see log base 10. So instead, we're going to write just log of y is equal to x. That's equivalent because, again, when it just says log, that means it has a base of 10. Pause the video right now and try the next 2 examples. Let's look. R to the t is equal to w. So log base r of w is equal to t. I always like to verify this by doing the base of r to the t power is equal to w. So keep the base and switch. Then for d, we have y is equal to e to the 3x. Again, I have a base of e. So log base e of y is equal to 3x, but log base e is the same as the natural log ln, so ln of y is equal to 3x. Again, verifying, I always do the base of e to the 3x is equal to y. Let's continue. Let's look at example 2. Convert the following equations from logarithmic log form to exponential form. So now we're working in the opposite direction. We're given a log and we're going to write it in exponential form. So notice log base 7 of x is equal to 2. 7 is my base. 7 squared is equal to x. 7 squared is 49. So 49 is equal to x. Let's look at b. X is equal to log base 3 of y. So it's 3 as my base to the x is equal to y. Pause the video right now and try the next 2 examples, C and D. Letter C, log of y is equal to 2. Again, there's no base. So if it's a log and there's no base, it's a base of 10. 10 squared is equal to y. 10 squared is equal to 100. And then for D, ln of c is equal to 4. ln, my natural log, I have a base of e. So I have e to the 4th is equal to c. Let's try some more examples. So for the next example, example 3, we are going to evaluate or simplify the following without using a graphing calculator. So I would like you to try examples A through D on your own by pausing the video now. My one suggestion for you all is to set them all equal to x, and then you're converting these 3 to exponential and solving. Pause the video now to complete these questions. If you notice, for letter A, 10 to the x power is equal to 100, so x is equal to 2. Letter B, log base 3 of 1/3. So log base 3, so my base is 3. 3 to the x is equal to 1/3. X is equal to -1. C, log base 2 of 32. So 2 to the x power is equal to 32. X is equal to 5. D, log base 3 of 81 is equal to x. 3 to the x power is equal to 81. X is equal to 3. Now, let's look at E. E, we have log base 5 of -25 is equal to x. So to convert this, I would do 5 to the x is equal to -25. This does not exist because the log of a negative number is undefined. F, log base 2 of 7 is equal to x, converted to exponential. 2 to the x is equal to 7. Now, we can't solve this because there's no whole number that we know. 2 to a whole number is not equal to 7. So unless we have our graphing calculator, we cannot continue to do this. So we have to leave this as log base 2 of 7. If we did have a graphing calculator, we would substitute this in and we would find a decimal approximation. Next, what I would like you all to do is try the next 6 questions on your own by pausing the video. So the next 3, log base 5 of 5 is equal to x. 5 to the x is equal to 5, so x is equal to 1. A shortcut here is if the base of the number is equal to the number next to it here, if those are the same, it's always going to be equal to 1. 8, log base 4 of 4 to the 6th is equal to x. 4 to the x is equal to 4 to the 6th. Because they have the same base, I eliminated the bases, so x is equal to 6. Now, I looks a little bit tricky, but it's really not. I said 7 to the log base 7 of 23 is equal to x. So what I did was I converted it by doing log base 7 of x is equal to log base 7 of 23. Now, if you notice, log base 7 is both on the left and the right-hand side. If that's the case, I'm able to eliminate the logs on both sides, so x is equal to 23. And finally, the last 3. So log of 1,000, there is no base there, so we know it's base of 10. 10 to what power is equal to 1,000? That would be x is equal to 3. K, ln of 1 is equal to x. ln has a base of e, so e to the x is equal to 1. E to what power is equal to 1? E to the 0 power. Anything to the 0 power is 1. So anytime we see ln of 1, that's going to be equivalent to 0. That will come up often in this class, so it's good for you to know that. And lastly, ln of e is equal to what? If I have ln, my base is e. E to the x is equal to e. X to the first power is equal to e, so ln of e is equal to 1. Another expression that comes up often in this class. Now I would like you to try these examples on your own without using a graphing calculator. Good luck! Thanks!